Find the effective area of the L-beam in inches squared. In this problem, a 2 by 2 by 1/8 L-beam is bolted to a plate and subjected to a force P. The bolts are spaced 2 inches apart with a given bolt diameter d bolt. The effective area of a steel member, AE, equals the net area of that member, A net, times the reduction coefficient, U. In this equation, the net area equals the gross area of the member minus the area from the holes. From a standard steel reference manual, we can look up that for a 2 by 2 by 1/8 L-beam, the gross area equals 0.484 inches squared. The area from the holes equals the quantity of holes for a given fracture path times the sum of the diameter of a single hole plus 2 times the damaged thickness around the hole times the thickness of the beam. The number of holes equals 1 because the beam will fracture through just one bolt hole. As a typical value, we'll use 1/32 of an inch as the damaged thickness around the bolt hole, and the diameter of the hole itself equals the diameter of the bolt plus 1/16 of an inch. Knowing the diameter of a bolt equals half an inch, the diameter of the hole equals 9/16 of an inch. The beam thickness for this particular size beam can also be looked up in a standard steel reference manual and equals 1/8 of an inch. After plugging in all the variables, the area from holes equals 0.078 inches squared. Therefore, the net area of the beam equals 0.484 inches squared minus 0.078 inches squared, which is 0.406 inches squared. Next, we need to determine the reduction coefficient, U. The reduction coefficient equals the smaller of 0.9 and the quantity 1 minus x bar over L. In this equation, L refers to the distance between the centers of the first and last bolt holes, which equals 2 inches. Next, if we take a cross-section of the beam and plate through A prime, we can identify the value of x bar as the distance between the centroid of the beam and the plane of connection, which for a 2 by 2 by 1/8 beam equals 0.546 inches. Therefore, after plugging in the values for x bar and the length L, the reduction coefficient is the smaller of 0.9 and 0.727, which equals 0.727. After plugging in the net area and reduction coefficient, the effective area of the L-beam equals 0.295 inches squared. When reviewing the possible solutions, the answer is A.